Hi, it's Carly McAvoy. Today I'm talking about solving word problems, and these are particularly mixture problems. But in these mixture problems, we are solving using one variable rather than two. So in the first question it says, how much water would need to be mixed with 20 liters of a 75% acid solution to get a mixture that is 60% acid? So just so you get a visual here, we have two different things we're pouring into one container, and we're trying to get that to change the acidity level from 75% of one down to 60%. So if you think about it this way, if we're first going to add some liquid, and when that goes in, we're going to have 20 liters, and let's say that that's at 75% because that's what the problem tells us, and I'm going to write that as 0.75. And then we're going to mix that with water. Well, how much acid is in water? Hopefully none. So we have some amount of water. I don't know how much. I'm going to call it X, and that is at 0%. Right? There's no acid in that. And that new level is going to bring this beaker up to some amount. And I don't know what it is, but I know that we put 20 liters in, and then we put X more liters in. So we have 20 plus X liters in this container, right? And we want that when we're finished, we want the acidity of that to be 60%. So I'm going to say times 0.6, or 60% when you move that over too. So everything inside the beaker goes on the left side. So I have 20 liters at 0.75, and I have X liters at 0% and then I have I'm going to put the 0.6 first. I have a 60% solution that is 20 liters that I started off with the 75 plus the X that I added for water. So this is how much is in the beaker, and this is the acidity that we want it to end up being. Hopefully you can see right here that 0 times X is just going away. So I don't have to worry about that. And 75 times 20 is 15. So I have 15 equals 0.6 times 20. Well, that's going to be 12. Plus 0.6x. And now if I subtract 12 from both sides, I get 3 equals 0.6x, and I'm going to divide both sides by 0.6. And I'm going to find out that x equals 5. So what is that telling me? What that tells me is if I have 20 liters at 75%, I need to add 5 liters of water to get that down to only 60%. So I need to add 5 liters of water. All right. So then the next one is it's another solution problem, but it's a little different. Justin has a 12% solution and an 18% solution. How much of each should he use to get 90 gallons of a 16% solution? Well, this is harder because we're not just adding water, which obviously made our calculation easy up here. We're going to have to add both things. So first of all, I'm going to put some amount, I don't know, let's say X at 12%. And I can't just say, oh, and I'll add Y at 18% because we're trying to use just one variable on these problems. So how many am I going to add? Well, this goes back to a problem type we did in the last one where we subtract. So you know you had 90 gallons altogether. You're going to have 90 gallons altogether. If you take away all the gallons of the 12%, what's left are the gallons of the 18%. So we're going to subtract. We're going to do 90 minus X. So we're going to take 90 minus X, and we're going to say that is at 18%. And that's going to give us a new level. So what we have in our container, then, if you look at it this way, we have 90 minus X plus X, right? And then we have they wanted it to be a 16% solution. Well, the way I wrote it is a little funny when you look at it this way, because what's 90 minus X plus X? It's just 90, because they told us we're going to end up with 90. So the way I wrote it, just to show you that that does come out to be 90 when I do it that way. What goes inside gets multiplied on the left side, so I have 0.12 times X, and I have 0.18 times 90 minus X. And then over here, I just have 90 times 0.16. So you can leave the decimals in that, or you can clear them out. I didn't clear the decimal out before because it didn't seem very hard to work with them up here. If you want to clear out decimals, I'm going to show you how. If you don't want to, that's fine. But if you multiply everything in here by 100, it's going to move your decimal points 2 places. And that basically just gets rid of them. So then you have 12x, and you have 18 times 90 minus x, and you have 16 times 90. And then you can work your equation without decimals. If you have a calculator, it just may not be worth your while to even worry about that. But what is 18 times 90? It's 1620, just I did that earlier. And I have 12x. And over here, 16 times 90 is 1,440. And then I can combine out my x's. That gives me negative 6x. 12 minus 18 is negative 6. And then I'm going to subtract 1620 from both sides. And that gives me negative 180. And dividing by negative 6 on both sides, you get x equals 30. Now, what I want to tell you is that if you're talking about how many liters of something you've added, you should never get a negative answer, right? You could add none, but if you add something, it shouldn't be negative. So if you get a negative answer, that's going to be a red flag that you did something wrong. Which one of these is 30? Is it the 12% or the 18%? Well, we said what x was the 12%. So I know that I have 30 gallons at 12%. And I know that I have 90 gallons altogether. So if I take 90 minus 30, that's going to tell me that I must have 60 left. That's 18%. So that's where the 90 minus x comes from. We just take away all the x, and what's left is the other amount. And that's going to be your answer to that. All right, have a fantastic day, and we'll see you next time.